Lesson 13.1, Task 4. All right, so it says model exponential data using piecewise defined functions. A piecewise defined function can be used to describe data that have different growth rates for different time periods. All right, so remember a piecewise function is just different, like pieces of multiple functions kind of put together on the same graph. All right, it says the population of Phoenix doubled from 5,500 in 1890 to 11,100 in 1900. In the tables of data shown in the graphing calculator screen, the t-value represents time measured in decades since 1890, and the p-value represents the population in thousands of Phoenix, Arizona. Create a model for the data. The scatter plot shown in the graphing calculator screen indicates that the data from time 0 to 5 appears to lie along the exponential curve shown in red, and the data from t equals 6 to 11 appears to lie along a different exponential curve. So you can see, here's what they're talking about. You can see that these first few points from 0 to 5 kind of fall in this red exponential curve. And then it looks like maybe a purple curve here that the other lines, these other points fall closer to this line instead of the first line. So there's actually two different exponential models here. All right, so they have written two equations. So the equation in red here is based on these first 5 points, and it has an A value of 6.63631 and a B value of 1.80421. It also has an R of 0.98, which again is a very strong regression, so that means the points fall very close to the curve, which you can see there. And then the purple line has an A of 1.04 and a B of 1.279. And then their R value is 0.99, so this is even a closer exponential curve based on these set of points. All right, so both of those are very good models to represent the data. And it says an exponential model from t0 to 5 is 6.6, you can see right here, 6.6, they've just rounded it, times 1.80 times 1.80. What is the growth rate for this model? Okay, so remember it's A times B to the t power, but B can be represented as 1 plus or minus your interest rate. So 1 plus 80% would be 0.80. Remember, 2 decimal places turns it into a percent. So it says, what is the growth rate for the model? Select the correct answer. All right, so the growth rate is not 80%, because you would move it 2 decimal places. Okay, so 80%. And that comes from, again, 1 plus your R. Okay, so if you do 1 minus R, that's the 0.80, and turn 0.80 into a percentage, you get 80%. All right, an exponential model from 6 to 11 is, again, this comes from the equation written in the calculator. You can see the A is 104, and the growth rate, B, is 1.28 rounded. And it says, what is the growth rate for this model? Again, it's going to be 1 plus or minus R. We can tell it's growth because it's greater than 1. And 1 plus R, my interest rate is 0.28. Change 0.28 to a percent, and that is 28%. All right, you can combine the models using a piecewise defined function. So if we look at the first function just for time, 0 to 5, and we can look at the second function from 6 to 11, and this would be our piecewise defined function. Okay, how could you estimate the population 5.5 decades after 1890? All right, since 5.5 is between 5 and 6, that means you could do the two models and then take the average. Anytime you have two numbers and you take the average of that. So it says evaluate both models, find the sum, find the difference, And the last one says find the average of the results. So what you would want to do is evaluate both models for 5.5 and then average your two answers to get the best result for something in between 5 and 6. All right, that is all for task 4. If you have any questions, please let me know.